Hello, it is I, your internet friend, Robert Guderian. Today we are talking about more numpy slicing. I would usually put this in the demo section, but I want to have as many demos available in this format as possible. We're going to get slices, we're going to assign values to slices, and we're going to see some stuff. So the first one is something we've seen before, 2D points, and we want to update everything to be bumped up by 1. So what I'm going to do is not just have random points this time. I want to actually have an x equals y line, which sounds crazy. So what I'm going to do is call it my points. And I'm going to start that off as np.zeros. And this is going to be a shape. I'm going to have a num points. And it's going to start off at 20-ish. Not ish, it's exactly 20. I want to have 2 columns and num, I need num points rows. And then 2 columns. Great. Now I want to assign the same values to all of these. So I'm going to use a slice. And I'm going to say points. I'm going to say all my rows and my first column, 0, is equal to np.linspace, 0 up to 100, and slice that into num points pieces. And I'm just going to make sure that runs. If I spell it correctly, again, you can spell it wrong, but you have to spell it consistently. And data does not exist because I renamed it points, and I stole this from a previous example. There you go. Points is a better name if you actually have something that's meaningful. And there you go. And they're all zeros. I need to do that for my y column too. And this will go straight up. On a previous slide, I had said that I wanted to, well, let's move them all up one first. Let's actually follow our directions. The slide says move the x column to be +1. So we're moving them all to the right. Let's do it. So I'm going to do that in green. I'm going to say points 2, where all rows, my x column is equal to the exact same thing. All rows, my x column plus, let's say 10, even though the slide says 1. This will be a nice visual difference. And name points 2 is not defined. That is true. We'll just modify it. This slice, if we're slicing into something, it does have to exist. If we're slicing out of something, it has to exist too. I could use .copy if I wanted to keep it pure. And you can see it shifted. Nice. So I am going to do that copy thing too. Points 2 is equal to points.copy, which will give me a copy. They are now separate. There is now 2 different numpy arrays sitting in my heap. And you've seen me draw that heap a number of times now. These are different. And if I modify points 2, points 1 is unmodified. Now what I want to do is do a log transform. And this is kind of a beautiful thing. I want my basically to say y is equal to log base 2 of x. That is what I want to do. But I have to do it in a slightly different way. Where I want to say points 2, and I want to have my y values, comma 1. So all rows, and then my y column is equal to points 2, my x column, points, all rows, and then my x column. And I'm going to use something called np.ln, log. Not going to help me. Great. And that will be a log transform. This is something that you do on data to kind of normalize it a bit. If you're doing lots of data analysis, this will become important to you. Let's do that in red. And we can see that nothing happened because I didn't name his points 2. Very important. That is very flat. It does actually curve. Let's get rid of these scatters so we can actually see that happen. I'm plotting it all on the same y-axis. It was happening, but it was just so flat you couldn't see it. So there you go. Why did I use linspace? Well, I'm dividing up the space of 0 up to and including 100 into 20 pieces. If I want more resolution, all I have to do is add a 0, and all of a sudden I have more spots. And you can see it turns into basically a line. Those are all points getting drawn, but I have higher resolution, and it's kind of pretty. Linspace is really handy for that. It's quite beautiful. So those are a few transforms, just x equals y, which is pretty and nice, and I really like doing that. And there you go. Our next problem is printing it out. So yeah, this is pretty much the same code, just shifting around if you don't want to copy it out of there. Update x values to +1 or if the y value is less than 10. Okay. This one I do need to draw out. Again, this is not for you. This is for me. Where we have some points. And we will be slicing rows. Because we're getting rid of rows. We're getting rid of points where y is less than 10. So less than or equal, I'll say 11. 12, 1, 2, 3. So we will be saying basically where this is less than 10. Keep those rows. Okay. Let's do it. So switching over my code. I'm going to say points 3 is equal to points.copy. Again, making just some new data set where I have something that I won't mess around with, and I can look at my data, and it exists. It is x equals y, which is fine, and there's way too many points to print out. I'm going to bring that down to 10 so we can actually make sense of it. I'm going to print points 3 just so I can see it. And there we go. There is definitely one that is less than 10, and we're trying to get rid of it. So points, I'm going to say maybe call it filtered. I want to have points 3 where my rows are where something is true. So this is within that first comma where points 3, and I'm looking at all rows, and the first column is less than 10. And then I'm going to print out filtered. There we go. And I only kept that one. I got the operator backwards. I want to keep them where I want to keep the ones that are greater than 10. And then there you go. I do that sometimes. Knots get kind of funny, and they're hard to keep track of, and that's why you test your code all the time. Double the row where the x value is greater than the y. I can actually do something cool here, where we have that, I can make a new scatter plot. So I'm going to say yeah, it's fine, is equal to np.random, random dot randint. I'm going to say from 0 to 100 because that's on the same XY scale. And I need a shape. So I'm going to say, give me 100 of, num points. That's why we have constant points. And I want to have 2 columns of that. Beautiful. So I'm just going to print scatter so I can see it. Scatter has 2 T's, that matters. And 10 points, looks great. So I want to print this out too. So I'm going to scatter plot this. It's going to make my log go away, but that's okay. And I'm going to print out scatter, and this will give me just a spray of data on my screen. Great. I will increase the num points to make it look really cool in a moment. I'm going to make them green. Green's great. Now I want to get rid of points where x is greater than y, or basically have a filter on that. So I'm going to call it scatter2 is equal to scatter. I'm slicing out rows, right? I'm getting rid of rows, where scatter, the first column, so the x's, are greater than the y. All rows, 1. This will, of course, return a numpy array of booleans, and then we can slice on that, and that's great. And then I can print out a second scatter plot, and I can paint over those, and I can paint them over. I have my colors here in magenta. Ooh. Oh, no. Oh, I did the exact same bug. That's so funny. I programmed this bug before. Comma 1. There we go. So I've painted magenta on all of them because I've got to put scatter 2. So we'll only get magenta on the ones where x is greater than, let's see, where x is greater than y. Yeah, so you can see the magenta is highlighted, and I'm going to put way more points, and this will look really neat. I'm going to give you 1,000 points, which will actually take a little while to draw. You can see that x equals y line pretty clearly now, can't you? If x is greater than y, it turns magenta. And it's kind of cool. And you can see it very clearly. And so instead of doubling it, I just printed it out. The spirit of it is still there. So numpy is expressive. We do have to think about what we're slicing on, and you can't just YOLO code this. You have to plan first. I am drawing them on the iPad. Again, not for you. It is for me. And if I don't do that, it takes me about 20 times longer. So plan first. I'll talk to you later.